Hi, I'm Cheryl Carmack with Charleston Waterkeeper.
And I'm Gwen Wallover with Mount Pleasant Waterworks.
We're going to be talking about how to measure transparency in tidal saltwaters using the South Carolina Adopt-a-Stream protocol.
Transparency, or the clearness of water, is a measure of light penetration into the water column. This measurement is affected by both color and suspended materials, like sediment or algae. Transparency can impact plant and algae growth, the amount of dissolved oxygen in water, and other water quality conditions at your site.
South Carolina Adopt-a-Stream measures transparency using two different methods depending on conditions at your site. These methods measure transparency in either meters or in centimeters. For sites that have low flow or are relatively deep, you can use a Secchi disc. For sites that have current or are relatively shallow, use a transparency tube.
You may have heard a different term called turbidity. Turbidity is a measurement that can be approximated from transparency. While transparency and clarity refer to the clearness of water, turbidity describes the murkiness or cloudiness of water.
Turbidity is determined by measuring how suspended material, like soil, algae, or phytoplankton, affects light penetration in the water column. The more cloudy the water, the higher the turbidity. The Adopt-a-Stream database calculates a site's turbidity during a sampling event from the transparency measurement reported at a site.
We'll talk more about the factors affecting transparency and turbidity in the transparency tube demonstration video. Watch these next two videos to learn how to measure transparency at tidal saltwater sites.
A Secchi disc is a flat, circular disc divided into alternating black and white quadrants suspended from a rope. The rope has 10 centimeter, 50 centimeter, and 100 centimeter markings to accurately record measurements. The Secchi disc can only be used when sampling from a dock, pier, or boat, as you must be directly above the disc when taking a measurement. This is why it's important that the current not be strong enough to move your disc while it's being lowered or raised. Before taking any measurements, be sure to remove any hats or sunglasses. You'll take two measurements with the Secchi disc, one as the disc is being lowered and one as the disc is being pulled up. Holding onto the rope and looking straight down at the Secchi disc, slowly lower the disc into the water. As soon as the black and white quadrants become indistinguishable, stop lowering the disc and record your measurement on the rope where it meets the water surface. This is your disappearance depth. Lower the disc until it is fully invisible and begin slowly pulling up on the rope. Take a second measurement at the point where you once again begin to see the black and white quadrants of the Secchi disc.
So here it is reappearing.
This is your reappearance depth. When taking your first measurement, if the disc hits the bottom and is still visible, record the depth and check Hit Bottom on your data sheet and in the database. If this happens, you won't need to take a second measurement. The database will average your two measurements for your final transparency result.
Hi, I'm Katie Callahan, here to talk with you about sediment in our streams. Many pollutants are naturally occurring and are only considered a pollutant when their presence in a waterway diminishes that waterway's ability to maintain life and could be considered a threat to the users. This is the case of sediment in our streams, creeks, lakes, and estuaries. Sediment transport occurs when water in a stream carries sediment suspended in the water column or along the bottom of the stream. A stream naturally carries sediment. As streams receive more sediment than their flow can transport, they become shallower and tend to widen, slow down, and get warmer. Warm water holds less oxygen than cool water, leading to declines in dissolved oxygen. Finally, sediment can disrupt stream habitat and clog the gills of fish. Assigning a numeric result to sediment load allows citizen scientists to record imbalances in our rivers, enabling resource managers to determine if further action needs to be taken to protect a waterway and ecosystem. We're using the transparency tube to record this measure. Transparency is the clearness of water, interchangeably known as clarity. Color, algae, phytoplankton, and suspended sediments can all alter this result. From the transparency tube, we can next approximate turbidity, which is the measure of the cloudiness of water. Measuring how suspended material in water affects light penetration into the water column. Turbidity can impact photosynthesis and water temperature and can be a signal to local resource managers of too much unmanaged runoff to a waterway. More on that later.
Let's learn the steps of using a transparency tube. I'm Emily Anderson, here to show you how. There are several different models of transparency tube, but they all work on the same premise: determining the depth at which you can begin to decipher the black from white quadrants of the Secchi disc inside the tube. First, be sure that your actions in the waterway are not impacting a marsh or stirring up bottom sediments. Approach your sample collection site from downstream. If flow and depth allow, you can directly submerge your tube. Otherwise, use a bucket to collect your sample from an area of undisturbed flow. Fill the tube with your water sample. Your sample should be well mixed, so feel free to cover the top and redistribute the water. For our model, the tube has a release valve at the bottom, releasing sample water when pressed down. This should be done on a solid surface, such as a rock. If you do not have a rock nearby or in the stream, carry a brick or find a sidewalk. Perform this inspection in the shade without a hat or sunglasses to gain the most accurate and consistent reading. Press down on the tube, slowly releasing your sample and looking straight down into the tube for the black and white Secchi disc to appear. Begin to slow down as you spot the disc until you can begin to differentiate the black and white quadrants. When you can discern the different colors, look to the side ruler to take your transparency reading in centimeters. When entered into the South Carolina Adopt-A-Stream database, this value is also converted to turbidity for you with the unit in TUs. A turbidity conversion chart can be found at our website.
Sources of soil erosion and soil loss include construction site runoff, farm field runoff, urban runoff from streets, ditches, and yards, and even sediment loss in the stream itself. High volume discharges from unmanaged impervious surfaces, such as parking lots, can leave a stream unbalanced. A lack of vegetation in the stream banks results in bank failure and increased sediment deposits. Being able to share transparency and turbidity data can provide valuable information for local action and policy development that addresses this pollutant in our waterways.